Good morning, good afternoon, or good evening, depending on where you are. Thank you for your interest in my talk at ICAM's 6th International Conference. My name is Cunha Silva, and I am a European College of Veterinary Public Health resident and a PhD student at the Veterinary Public Health Institute of the University of Bern in Switzerland. My presentation today will focus on demographics of free-roaming dogs in Guwahati, India, specifically assessing population characteristics and comparing population size estimation methods. As many of you are probably aware, India bears the highest global burden of rabies, accounting for approximately 35% of all human rabies deaths worldwide, with free-roaming dogs playing a critical role in the spread of the disease. For the purpose of this study, free-roaming dogs are defined as dogs not confined and under no direct human supervision, as defined by WOA. Accurate free-roaming dog population estimates are crucial for effective dog population management and mass dog vaccination strategies. In India, estimating free-roaming dog populations is a key objective listed on the National Action Plan for Rabies Elimination. There are various methods described in the literature for estimating the size of free-roaming dog populations. Photographic site-resite surveys, however, using maximum likelihood estimates, are recognized for estimation of free-roaming dog populations. Additionally, the online tool application superduplicates has also previously demonstrated its ability to produce reliable estimates and only requires 2 surveys. So our study will focus on these 2 methodologies. While several studies have assessed free-roaming dog demographics in India, none have focused on Northeast India, particularly Assam. So this study characterizes free-roaming dog demographics in 2 urban settings in Guwahati, Assam, estimates the free-roaming dog populations using program MARC and the application superduplicates, and evaluates superduplicates as a less resource-intensive alternative to program MARC for population estimates. For the purpose of this study, photographic capture-recapture surveys were conducted in 2 distinct locations in Guwahati, a market area without defined boundaries and a gated university campus. The study locations can be seen in the figure to your right. Daily consecutive surveys were implemented to minimize demographic changes and satisfy the closed population criterion of closed capture methodologies. The market area surveys were exclusively done in the morning, adding up to a total of 5 surveys. On-campus surveys were done both in the morning and evening, adding to a total of 8 surveys, 4 done in the morning and 4 in the evening of the same days. For the sake of time, I will not go into detail regarding the deployed methodology, but information on it can easily be found in the scientific literature. Here you can see me conducting one of such surveys in the market area in Guwahati. So, this study has 2 main components: population size estimation by 2 different methods, superduplicates and program MARC, and its comparison, and characterization of the core demographic characteristics of free-roaming dog populations in Guwahati. Regarding population size estimates, close histories of all observed free-roaming dogs were analyzed using program MARC software. Huggins closed capture heterogeneity models with jackknife and chow estimators were used to estimate the population size. Then the online application SuperDuplicate Shiny app was also used to calculate population size, but only using the first 2 consecutive transects at each site. Additionally, all possible 2 consecutive survey combination estimates were calculated via superduplicates to evaluate if different temporal combinations may affect the estimates. The degrees of concordance between population estimates obtained from superduplicates and those generated using Huggins models in MARC was then assessed to evaluate the consistency between the estimation methods. Regarding demographic characteristics, sex, age, size, body condition, whether the dogs were notched or not, and whether they were collared or not, were the characteristics considered. Differences between population characteristics at each site were assessed using either the chi-square test or the Fisher's exact test. So, what did we find? Starting with demographic characteristics. Here you can see some of the sighted dogs in the market area, the top 3 pictures, and some of the sighted dogs on campus, the bottom 3 pictures. A total of 183 unique free-roaming dogs were sighted in the market area across the 5 days of surveys. In the gated campus, the total unique sightings were 141, with almost equal sightings from morning and evening trails. Most captured dogs were medium-sized adult males, not notched and not collared, with good body condition. Significant differences were found between the sites. Significant statistical differences were found in regards to sex, age, size, and sterilization status between free-roaming dog populations. Free-roaming dogs in the market area were generally younger, in poorer physical condition, and with lower sterilization rate compared to the campus population, as you can also see from these pictures. Moving on to population size estimates. Given the absence of a universally accepted gold standard methodology for estimating free-roaming dog populations, this study employed Program Mark as the optimal methodology, or its gold standard. So I will start with Program Mark estimate results. We use all 5 surveys for the market site estimates and all 8 surveys for the campus estimates. The population size using the Chow estimator at the market site was estimated at 252 individuals and 164 individuals on campus. At the campus site, due to temporal variation in transects, meaning we had morning and evening surveys, only Huggins heterogeneity models with the jackknife estimator were used to estimate the population size. The morning and evening transect data, considered separately, gave the estimate of 161 dogs in the morning and 153 dogs in the evenings. When we estimated together the total population, meaning we considered morning and evening surveys combined, we obtained a result of 169 dogs. For the estimates using superduplicates in the campus site and the market site, the first 2 consecutive surveys were used to calculate the population estimated size. The estimated population size was 229 individuals in the market area using survey from day 1 and day 2, and 178 individuals on campus using surveys from morning 1 and evening 1. At the campus, the population was further estimated at 159 individuals in the morning using surveys from morning 1 and morning 2, and 141 individuals in the evenings using surveys from evening 1 and evening 2. Greater variation was observed in the campus size estimates compared to the ones from the market. At the campus site, higher average uncertainty, meaning larger confidence intervals, were found for estimates calculated from surveys with mixed time periods, meaning these that considered both morning and evening surveys, compared to estimates obtained from surveys conducted during a single time period, meaning those that consider only evening surveys or just morning surveys. We have discussed that accurate knowledge of free-roaming dog population sizes is essential for designing effective vaccination strategies tailored to local implementation contexts and on-the-ground realities. Therefore, a discrepancy threshold of up to 30% between estimation methods was considered acceptable for evaluating the practical utility of alternative population estimation tools, in this case, superduplicates. Our results indicate that even in the most divergent cases, superduplicate estimates did not deviate by more than 30% from those produced by Program Mark. This level of accuracy supports and validates the use of superduplicates as a practical and efficient tool for informing rabies control initiatives and dog population management strategies. So, our study is the first to report free roaming dog enumeration in Northeast India. By providing insights into the structure of the free roaming dog populations in two diverse habitats in the city of Guwahati, the biggest urban center in Northeast India, using two distinct methods of estimation, programmark and superduplicates, this work serves as a guidance for estimating dog population size for ongoing dog population management and mass dog vaccination initiatives in Assam. From this study, we were able to conclude that application superduplicates does offer a robust alternative to programmark for estimating free roaming dog populations, providing reliable results with reduced effort. Demographic variation in free-roaming dog populations can occur at fine spatial scales, even between neighboring study sites, as we saw with our market and campus sites. And so context-specific planning is essential for mass dog vaccination and dog population management strategies, even within the same administrative regions. Lastly, I want to thank you all for your attention and especially thank the ICAM team for having me today. If this presentation has piqued your interest and you would like to know more about our work in Assam, then please do reach out using these slides information. I am now open for questions. Thank you.